Hi, we're going to learn how axes correspond to the different values for the gyroscope and how we can use these different component values to understand how Pocket Lab can move in 3 dimensions. So I have my software running, my app running, and it's paired to the sensor. So I'm going to click on the gyroscope. And we're going to be able to see the data coming through. And if you notice that there are 3 components to the data, there's an X, Y, and Z component. And this corresponds to red, blue, and green. And I have a set of axes here to represent those values. So X is my red arrow, Y is my blue arrow, and Z is my green arrow. And we need 3 components to represent motion in 3-dimensional space because, as we'll illustrate, we can rotate about any of these axes. So the axes correspond to the sensor in this orientation, with X, Y, X being the red, Y being the blue, and green being Z. So if we look at the data and my hand's not super steady, we can see that all of the values are sort of hovering around 0 degrees per second. And what our gyroscope measures is angular velocity. So it's measuring the rate of rotation. So if I were to rotate my sensor about this axis, the y-axis, I would do so by rotating it like that. So that would be a positive rotation about the y-axis. And this is a negative rotation about the y-axis. And that's just a convention so that we can represent these values with positive and negative numbers. So I have here a little turntable. And we can use this to look at the output of the gyroscope. So again, when I'm oriented like this, and I rotate the turntable, if I rotate it according to the right-hand rule, if you put your thumb in line with the axis and curl your fingers around, if I rotate it this direction, we should see a positive angular rotation. And so I'm going to do it slowly at first. And you can see that, for the most part, our angular rotation is only about the z-axis. And we're at somewhere around 20 degrees per second. So that's pretty slow. Now, if I rotate it in the opposite direction, we should see a negative value. Because our convention is that when we're rotating about the negative direction, we're going this clockwise, and that corresponds to a negative angular rotation. So I'm going to rotate it very slowly. And you can see that we're traveling at about minus 30 degrees per second. So we're measuring angular velocity. So what that means is the faster we spin it, the higher our angular velocity is. So now I'm going to spin it a little bit faster, and we should see the values go higher than in our previous run. And if you can see on the screen there, we're at about 200 degrees per second. Stop. Now, if I wanted to sort of look at rotation in a different axis, or I just wanted to understand the orientation of the sensor, I could, let's say I can flip Pocket Lab to rotate about the z-axis. So if I flipped the sensor, I should also flip my coordinate system. And now I'm going to rotate about the green arrow, which represents the z-axis. So you should see now the green value is what increases as we rotate the turntable. Let's try it. We're rotating in the positive direction, and you can see it increase. And then we will rotate in the opposite direction, the negative direction. And there you go. That's how we represent angular rotation in 3 dimensions using a coordinate system and 3 values. Thank you.